Hello, and welcome to Top 10 Features of ADS 2023. In this video series, we are talking about all the latest enhancements in the ADS. In this video, we will focus on parametric EM circuit co-simulation and co-optimization. Using this new capability, you would be able to operate on your parametric EM subcell to perform parameter sweep, optimization, or statistical analysis. So this is a pretty cool capability which allows you to get EM accuracy as well as the flexibility of circuit simulation. So let's see how all this can be accomplished for your own design work. Now, in order to prepare, we need to do three basic preparation, which I would recommend. First, let's set the ADS operating mode from interoperability. So you can choose any of these modes. However, since the new view which we are going to generate will be fully interoperable, so you can decide to switch on interoperable mode only if you regularly work with third-party software such as Cadence Virtuoso, so that you can access the design in both of the environments. The second mode is obviously to have a combined legacy and interoperable mode, and you can pick and choose when to work in legacy mode, which is native ADS, or in an interoperable manner. So it's pretty flexible. In my case, I've selected the third option. The second preparation I would like to do based on the test bench from where I would run simulation. In the simulation settings, we can choose the right hierarchy policy. Again, since the view which will be interoperable, it's recommended to use either IC or ICEM mode. With these approaches, you would be able to simulate any interoperable view of the components. That's preparation number two. In terms of third preparation, we need to add a library which is called as EMPro Basic Library, and this library can be added by simply clicking on Add Library button, browsing to the ADS installation folder and the path which is shown here. And during addition, you can simply select it to be read only so that you do not see those components in your workspace. But now the software has the capability to pick and choose any of the component required to create the schematic subcircuit. So with this three simple basic preparation, you are now ready to utilize the new capability. Now the test circuit which I have here is a microstep line based output matching network for our power amplifier design, and here you can see all the primitive P cell components which are used in the design. Now, any of those P cells, you can go ahead and assign the variables of your choice. Like in this case, the width of the line is declared a variable, and also length of this open circuit step is using a variable. Now, once those two variables are defined and initialized with a certain value, we can set up an RFPro sweep where we can define the parameter sweep criteria. Here you can see I have L step variable changing from 6 to 7 in an increment of zero point 0.2, and the width of the line is changing from 1 to 2 in increment of zero point 0.2. Very simple. And both of them are defined in a nested sweep manner, resulting in overall 36 simulation. After this, we can go ahead and run the entire simulation. And once it is finished, we can look at the S parameter response. However, looking at S parameter response in isolation doesn't give you any useful information, and rather we would like to take this information back to circuit. Now also notice here, I do have four SMT components for capacitors, and they have been added in the component model. And now once we generate the subcircuit of this result, now the resulting schematic will have all these things stitched together automatically along with the parametric EM data view. Here you can see four SMT capacitors with the EM input model, and they are already interconnected with each other. And this is a great advantage for designers because they do not need to spend any time in manually connecting all these, because for large number of components this could be very time consuming as well as error prone step. Now here, if you double click on the EM data, you can see there are two data parameters, that means variable, and you can see the variable name and the initial value on which we created these variables in RFPro. Now to make it a parametric subnetwork, we need to do two things. Number one, we need to assign a variable in this component and also assign those variables in the design parameters so that this schematic becomes a parametric schematic subcircuit. In order to help you with that, for the current release, we have developed an AEL add-on utility. You can download this utility using the link provided in the description box, and once you install it and simply click on this option, your circuit will be fully updated with the required configuration. Here, if I double click on this component again, you can see now the value is declared a variable, and this we have selected the same name as we created in RFPro for better understanding. Also, in terms of design parameter, the utility will configure these two variables to be defined as cell parameters. So pretty convenient. And now you are ready to use this network in a top level design. So let's go ahead and look at our top level design here. And we can simply drag and drop this symbol, place it here. And now you can see with this network, you have two variables attached. Now these variables can be optimized, fine tuned, or whatever you want to do. So here, let me go ahead and define the variable name which I want to use. And here you can see I have created two variables, and same can be assigned in this parametric model. Pretty cool, right? Now, along with the generating the schematic equivalent circuit, RFPro also generates this EM data container, which has the database of all the EM results which you have performed. And to make it more suitable to be used in circuit simulation, we can simply switch on the interpolation, set the interpolation delta so that even if you are using any value in between, which is not part of your database, the model will be interpolated properly. So pretty simple step. And now we are ready to perform any operation we want. Now we can go ahead and select the right view, which is the P cell sweep view, which is the subcircuit created from RFPro. And now we can perform parameter sweep. So let me show you that. So once we run parameter sweep, you can see the simulation will progress. And here I'm running parameter sweep in zero point 0.1 mm increment. And due to the interpolation which is switched on, there will be no problem in you observing the full parametric circuit response. Now, after parameter sweep, we can also perform optimization in order to meet our desired goal. And here, by switching on our optimization, you can see I have three goals for the gain and input and output return loss. And I'm optimizing these EM parameters along with the rest of the circuit component parameter, which are still used as a circuit model. So this is really EM circuit co-optimization. And here you can see an optimization cockpit window, the variables are being modified. So you have the circuit variables as well as you have two variables belonging to the EM model data. And once you have the goals which are satisfied, you can go ahead and update your design. Both circuit model as well as EM model parameters will be updated. At this point, let's go ahead and run a nominal circuit simulation. And now you can see we are meeting all the required specification as we defined for our circuit. Pretty seamless, right? So pretty cool. Now the last thing we can do, of course, is to run a statistical analysis. Here you can see both of these parameters which were declared as optimizable also has statistical definition of distribution defined. So using those function, we can operate on this parametric EM cell pretty much like how we operate on any schematic cell. So let's go ahead and run Monte Carlo simulation. And now you can see the simulation is working seamlessly. And now you can observe the spread of the circuit performance due to variation in the EM parameters. Pretty cool and pretty straightforward. All right. So that's all I wanted to show you in this demo. Just to re-stress the point, now you can not only perform a parametric EM simulation, you can also bring the data seamlessly into ADS to perform circuit simulation, do things like optimization, real-time tuning, parameter sweep, or statistical analysis. It's all possible now thanks to all the enhancements in ADS 2023. Thanks for your time to watch this entire video and wish you all the best in your design work. If you have any further support requirement, please feel free to contact your local Keysight support person. Thanks again and wish you all the best.